This is the code walkthrough for ME-3902 final project. So right here is the potentiometer circuit that's shown in the full circuit video walkthrough. Right here it's just declaring the analog input as pin slot A0. All the LED pins are synonymous with the PWM slots on the Arduino Uno board. And it's establishing the original input value and sensor value and output value all is 0. Then lamp state is deemed a Boolean variable, which it's declaring as false. This is just going to be for the entirety of the lamp 3D printed model that the circuitry is actually inside. More on the state there, which is later in the code. Next, we have the fan circuit, which is very simple. It's just establishing the DC pin as pin slot 2 on the Arduino board. Then there's the thermistor circuit, which is including these libraries with the Adafruit since it involves an ADC component. Right here is declaring volts as ranging from 0.0 to 4.1 volts. It's only in the 3.3 volt slot, so that's expected to be the maximum. These values right here of A0, A1, and so on are the components that were found, are the coefficients that are found based on the specific thermistor model. And then float is just going to be measuring the temperatures in degrees Celsius, and it's starting the start time at 0. Once again, we come down here with the setup, and that's just establishing the serial monitor at 9600. The LEDs are deemed outputs, the DC motor is deemed an output, and the thermistor is being coded with the ADS for a gain of 1, and the time is in milliseconds. Then you come to the LED circuit functions. It's converting the analog signal of the potentiometer into output values for the LED lights, so it lights up and gets brighter based on the position of the analogous signal from the potentiometer. And then it prints here for the serial monitor saying the potentiometer and the sensor value and the LED value and the output value, which are 1023 and 255 respectively. So when this next if statement here is saying if these max values are achieved, then the lamp is deemed on. This is set to simulate if a lamp's overheating at maximum capacity, which would cause the whole need for the DC motor to kick in. If it's not at that, it's deemed false. So as you saw in the video, the motor will not kick on unless it's at full capacity or full function. Then the thermistor circuit, it's saying if the lamp is deemed on, then the thermistor will kick on to measure the temperature. This would serve to measure overheating. So it's taking the raw ADC value and dividing it by this constant that was found online and multiplying it by the maximum voltage. The temperature is in degrees Celsius with the constants mentioned above. And then it's just printing out all of these values of the time that's elapsed, the voltage that's being measured, and the temperature in degrees Celsius. Then the fan function is the last sensor. It's saying that if the temperature is above 20 degrees Celsius, then it's deemed overheating, so the DC pin kicks on high, and if else not, it's deemed low. The reason for this is that we can't actually get enough heat out of the LED, so it's set low in order to simulate that the functionality of it works, and if someone actually wanted to implement it, then they could just change it based on whatever the values are. So just to prove it works, I'll run the serial monitor. The serial monitor starts off with the potentiometer and the LED value. As it turns, you can see it increases. The DC motor's not kicking on. And then once it switches to that, it's really quick, but it measures the time, the voltage, and the time in degrees Celsius. As you can see, before it works, and then it kicks off, and it resets the potentiometer and LED value of 0.